And section 5.3, formal definition of antiderivative and indefinite integral. We're getting started on these now, and these are really nice. I think you'll enjoy today's lesson. It'll be pretty short and easy for you to work through and understand. We want to become familiar with the symbolism of antiderivatives and to evaluate indefinite integrals. And you do need to know that when you see the word antiderivative and the word integral, that those are used pretty much interchangeably in most things. When we say indefinite, it means we are not having any bounds on our area that we are finding at this point. And so these are nice problems. You don't have to worry about too much on these. Okay. As I said, antiderivative, indefinite integral, those are used pretty much interchangeably. This is when we finished yesterday's lesson. We were looking at this problem right here. That's if you did section 5.1, I believe it was, and we'd gone over it. We wanted to find the antiderivative of y, and another way to write that, besides just saying this right here, besides looking at it like this and saying find the antiderivative, this is your symbolism. Okay, this little symbol right here, that's your integral symbol. That means find the antiderivative of this function right here with respect to x right here. Okay. The integral sign is the little swirly s. It was used for sum. Okay, the 3x plus 7, 5 is your integrand. And the process of finding it is called integrating. So shouldn't be a big deal on any of this stuff that you've seen before. Okay. When we look at an indefinite integral, a lot of the books will say g of x equals the integral of f of x dx, if and only if g prime of x equals f of x. Some books will use capital letters. They'll do f of x equals an integral of f of x dx, if and only if f prime of x equals f of x, and that type of symbolism. So, and there's your if and only if with that symbol, or you could use if and only if with that symbol right there. But that's pretty much what you're looking at on these. One of your books will have one of these two symbolisms. Okay, verbally, the expression integral of f of x dx is the integral with respect to x. Pretty easy stuff. An equivalent equation for g prime of x equals f of x is the derivative of the integral of f of x dx equals f of x. This equation right here is going to be really important in the future, so be sure that you get it down and think about what we're saying. We're saying if we integrate this and we get f of x, and then we take the derivative of that capital F of x, we should end up back with our little derivative there. Okay, so that's what we're looking at. Okay, these are just some basic properties of indefinite integrals for you to get copied down. If you have a constant times a function, then the constant that's written right here can be pulled out to the front and not affect your integration at all. Integral of a sum of two functions, I can integrate each one of them individually. When I do the integral of a power function, and this is one that you've done before, you just hadn't thought about it being in that form. If I integrate x cubed dx, then I know that that had to go to x to the fourth over 4, okay, plus c, so that when I take the derivative and my 4 comes down, it cancels and I'm left with the x cubed that I originally started with. So you've done that before, you just hadn't thought about it quite in that form, but that's a really nice thing there. The integral of the natural exponential function, you know that the derivative of e to the x is e to the x, so therefore the integral would have to be. We've got e to the u du here, because sometimes we do have to worry about something being up there besides just plain old x. Sometimes it's a 2x, right? All right. All right, from this point on, all that I want you to do is pause the tape, figure out the answer, start it back again. I'll have the answer up there, and you see if yours matches. If it doesn't, try to figure out what the problem is. And if it does, woohoo. And if you can't figure out the problem, star it and ask me tomorrow in class. All right, so here we go. Don't don't forget the plus C, super important. Derivative of sine. If I were to take the derivative of this to check it, I'm just going to show you this one real quick. I won't do this on the rest of them. Derivative of sine of 5x plus 3 plus C. Derivative of sine is going to be cosine of 5x plus 3. Derivative of C is a constant, so it goes to 0 by your chain rule times 5. And yes, I do end up with what I started with, so I'm good. All right, next one. Again, pause it. See what you get. Derivative, if you are not sure that that's correct, and double check me, but that's what you should end up with. All right, again, pause. Next one may be a little bit tougher as you stop to look at it. Remember that we had our original thing. If I was taking the derivative, we'll start with this for just a second and remind you. So my derivative of 5 to the x, remember, was 5 to the x natural log 5. Therefore, I've got to offset that whenever I'm integrating. So again, pause, stop the tape for just a second, see what you come up with, then come back to me. Hopefully you did it like this and made that fraction there so that when you would take the derivative of this, that natural log 5 would cancel out. And there you go. There's your homework, and that's it for today. Thanks. Bye.